Welcome to Intro to Functional Programming in Haskell. Today we'll be talking about Foldable, Traversable, Reader, and State. The purpose of the Foldable type class is to describe structures that can be summarized into a single value. Foldable is heavily reliant on a concept that we've already discussed, monoid. Foldable structures are summarized using monoid's apply. To successfully define a foldable, one needs only to define Foldable's function foldMap. If one looks closely at foldMap's type declaration, one might be able to see that foldMap simply takes in a function that translates A's to M's, where M's are monoidal, and then executes that function over a structure of A's to produce a structure of monoidal values. Once we have a structure of monoidal values, it is then easy to repeatedly execute apply over these values to summarize the structure into a single result. How to actually execute apply over each of the M's in the structure of M's is actually up to the user to define within the foldMap function. The T structure could be a binary tree, in which case one would have to define how to traverse the tree, applying apply appropriately. But also the structure could be something as simple as maybe's just constructor. One can have a value of just 3 or just 5. Apply over just 5 would just be the identity applied with 5. The next related and similarly useful type class is Traversable. It is best to realize what Traversable does by first looking back at some of the other type classes we've just recently discussed. So let's say we had a tree of values, let's say a tree of ints. Foldable's foldMap would somehow summarize this tree of ints into a single value. We could use addition as the monoidal instance, so this tree of ints would essentially become the sum of all of its parts. We could have a functor instance for the tree, in which case the functor's fmap would simply cause a transformation on each of the tree's values. So if we had a function that simply multiplied by 2 passed into the functor fmap operation, the tree of ints would have all of its values multiplied by 2. Its structure would be preserved. The tree could have an instance of traversable. Traversable's traverse goes over the structure of the tree and produces a new tree of the same structure, but as it's executing over the structure, could execute applicative effects and add additional applicative structure. It is essentially an enhanced version of executing a functor function over the tree. The reader type class contains a function that goes from values of R to values of A. The functor instance of reader takes a function from A to B, and the reader itself, which goes from values of R to values of A, and produces a new reader, which goes from values of R to values of B. So what's going on here is that the contained function is iteratively being composed with new functions in a way such that new computational context can be built up within the reader. State is highly related to reader. It has a contain function. However, this contain function takes a state and produces an output value along with a new state. So using state, we can build up a context of interdependent functions that process a state, alter it, and then pass it on to the next step in the process.